And I will introduce you to Sean Griffin. So Sean Griffin is the founder and CEO of Disaster Tech. He served as the Director for Incident Management Integration Policy on the U.S. National Security Council at the White House and is an active duty veteran of the U.S. Navy and Navy Nuclear Power Program. During his White House term under 2 U.S. presidents, Sean led the Executive Office of the President and Interagency Policy Coordination for Major Disasters and Incidents. Additionally, Sean led emergency management training and exercise programs at the U.S. Department of Energy, Department of State, Defense Logistics Agency, and National Institutes of Health. He also volunteered time to chair the Federal Sector Emergency Managers Caucus for the International Association of Emergency Managers, and is a leading member of the Private Sector Committee for the National Emergency Management Association. So I'd like to welcome Sean. For everyone else, if you have questions, please feel free to type this throughout his presentation. I will share these with Sean for the last 15 minutes of this session. So around 9:30, we'll flip over to Q&A period. So I would like to welcome Sean.
Thank you, Laura. And I'll just share my screen so y'all can see that, I assume. So good morning, and thank you so much, Laura and CatIQ, for having me today to keynote this really incredible event, talking about the use of technology and where technology is going with respect to catastrophic loss and risk management and disasters, not just in Canada, the United States, but around the world. And AI applications, there are risks and rewards that go into it. Certainly AI is not new, but it is now new and novel to, I think, the broader sort of macro discussion of how we're using technology. And there are gaps in the use of artificial intelligence, machine learning, but there's a lot of promise, and I'm going to get into that today. So as mentioned, I'm the co-founder of Disaster Technologies Incorporated, or Disaster Tech. And we are a public benefit company that has a mission to reduce risk before, during, and after disasters through the use of decision support technologies to provide situational awareness, to coordinate an operation, and to plan with your partners, whether it be in public or private sector. A bit about my background. I did serve in the US government, as mentioned, both at the State Department, Department of Energy, where I worked with Public Safety Canada, Natural Resources Canada on issues such as the Arctic Council, as well as cross-border disaster relief missions. And there's challenges, right? You have a US national, or excuse me, a North American grid that does not respect boundaries. There are significant risks and fragility to our grid systems and infrastructure systems that go cross-border, in which we all rely on, both on the US and Canada side. And really looking at not just from risk from communities to homes, but also to infrastructure and human capital. And we need to look at this as a system of systems in artificial intelligence. And one of the benefits is that, you know, in disasters, especially in the early onset, time is everything. As the Navy SEALs say, speed kills. And AI can help with accelerating that decision support and situational awareness and damage assessment in the early onset of a crisis to help accelerate the recovery and restoration following a disaster. So the current state of affairs, you know, the way that we're doing risk management, frankly, is outdated. It's still a lot of paper, clipboards, assessments, boots on the ground, and we really need innovation to take a front seat, using things like remote sensing technologies, leveraging satellite imagery, drones, the Internet of Things. You know, we have so many connected devices, and it's only exponentially growing, which means there's more data than there ever has been. And because there's more data, that means that we need technologies to be able to handle the volume and velocity of that data, which is coming in order to harness it in real time. Because the last thing we want to be with respect to saving lives or reducing risk in disaster is being late for need. And in order to not be late for need, we have to have the infrastructure, the compute, the algorithms, the data pipelines, the data quality, in order to leverage these technologies to our greatest advantage, as well as at the highest efficacy. So here's an example study that came out of Lehigh University that talks about the use and application of artificial intelligence in disaster and risk management. And as you can see, there's been a spike in increase over time. But if you look at the color code in purple, disaster response artificial intelligence, the majority of the application and research around the use of AI in disaster management is within the response phase. But as we know, that as the National Academy of Sciences in the United States say, $1 spent in mitigation is a $6 return. And so we need to be thinking about how do we leverage more artificial intelligence application, not so much heavy-handed in the response side, but also in mitigation and preparedness, which is clearly underrepresented, where most of the applications are in the response and recovery realm. In addition, the other benefit on focus on mitigation versus response as it relates to AI and machine learning is data availability. We're in a much more rich data environment with respect to blue sky planning pre-event than we are in a response. As we say, each plan never survives first impact because every plan that we build for responding to a crisis is based on a set of assumptions that we're assuming will happen in the future, which we know inevitably fail. But we want to try and make those assumptions as best as possible to understand what future risks may look like so that we can best mitigate it pre-event in blue skies, but certainly be able to deal with things quickly after a catastrophe happens. So again, AI risk and rewards. This is really the title of my discussion. And I've already alluded to that there's challenges with respect to the response immediate after the fact use of AI. The fact that the data was not available in blue skies, where in the response, the data is now available. But how do you train a model to that to be able to leverage it for disasters? And again, going back to the disparity in focus, in this paper, you'll notice that they've mapped the various types of artificial intelligence methods to the traditional 4 areas of disaster management: mitigation, preparedness, response, and recovery. And again, the majority of the applications are in the response phase. And not surprisingly, a big emphasis is using artificial intelligence to try and assess the damage post-event. But there are challenges. For example, when looking at a wildfire, using such as a binary classifier to understand which homes have been destroyed by the fire or not, that binary classifier is very helpful because you can see, okay, this house has been burned, either by looking at its heat signature or the fact that it had a black roof and now it's white and ashy because of the ash signature on the ground. It's much easier to identify that. Whereas in a flood, looking at a 2-dimensional picture, it's very hard for that machine learning model to ascertain what's the height of the floodwaters, what's the extent of the floodwaters. What we need to do as it relates to the use of artificial intelligence is take more of a hybrid approach, where we do not throw out the proverbial baby with the bathwater. We need to keep physics-based models and more traditional qualitative models in our disposal, in our toolbox. We need to look at AI as not a panacea, but rather as another tool in the toolbox that has value in some applications and has really no value in some other applications. As the saying goes, all models are wrong, some models are useful, and there's no such thing as 100% in statistics. So we have to use these models to where, number 1, there's efficacy, number 2, speed matters, and number 3, the data that is available for training, both in blue skies, provides the quality and the efficacy so that when the models are created, you're reducing bias and error as a result. And certainly we don't want to use underconfident or low confidence models as it relates to saving lives or deciding things like, in the United States, one of my responsibilities was, well, let's figure out what the supplemental package or funding would be to recover this community. And if I'm overestimating or underestimating the spend as it relates to how much money do we send to this community to recover, that could only prolong the recovery and only put survivors at an unfortunate risk. So the impact on AI has on bias and data quality. At the end of the day, artificial intelligence is a model that is trained by humans, and humans have to tune that model one way or the other. It's going to bias it naturally based on the human's understanding of the issue at hand. It's going to bias its based on the person or the people who are building the model and training the model on their institutional understanding. Many of these models that have been created for AI applications are not being done with practitioners on the ground. We are a founding member, Disaster Tech is, of the National Science Foundation AI Institute for research on trustworthy AI on climate, weather, and coastal oceanography. And there's a key word in there, trustworthy, right? We need these models to be trusted, not just by the researchers who build them, but by the practitioners and by the public who rely on these models to make life-saving or risk mitigation decisions that may affect a community for decades and generations to come. So what we're focused on in the AI Institute is an R2O approach, or research to operations, where we are flanking practitioners and operators and risk managers alongside the researchers to ensure that when it relates to building and constructing the model, that they have a better sense of what types of data to look for, as well as to ensure that the model has an end state and an objective towards meeting an operational goal. That is, if me as a risk manager goes into the field to leverage this model for decision making, that it actually has the types of tasks and procedures that I'm looking to accomplish as it relates to the model run. And having access to HPC equipment or high performance computing, 5-10 years ago, it was nearly impossible to get access unless you worked at a university or a government agency or a national lab here in the United States to have access to high performance computing infrastructure to be able to run these models. As I mentioned earlier in the discussion, that the volume and velocity of data coming in as more connected devices, being able to pull in more data, as you're bringing in satellite imagery, that's a large data footprint. You have to have the compute to be able to deal with the data that is provided to you. The great thing is that companies like NVIDIA, who produce GPUs or graphics processing units, and even Intel on CPUs, have really reduced the price of that infrastructure. And cloud computing has really changed the game, where really the intersection of artificial intelligence, cloud, and high performance computing is converging to allow access at a much more democratized level than ever before, because it's just much more cheaper. So if you go to Google Cloud, you go to Microsoft Azure, you go to Amazon Web Services, IBM, Oracle, they all have the ability to run GPUs in the cloud and have access to high performance computing, where you don't have to go to a national lab or an expensive university to take advantage of it. Frankly, it's pennies on the dollar. And if you look at the use of GPUs and new technologies like Rapids.ai, which is built on the Apache Arrow Foundation Arrow framework, as well as other Apache Foundation open source tools, and open source means free. So really the biggest gap right now that we have is a technical skills gap. We need to shore up that technical skills gap so that we have professionals who have that blend of practitioner skills and technology skills to be able to take advantage of these HPC, AI, and cloud technologies in concert with one another to leverage these models for the real-time application. And as mentioned earlier, $1 invested in disaster mitigation saves $6. And the average annual bill for disaster assistance over the last 3 years, according to Public Safety Canada, is about $430 million. These numbers are staggering. It's economically unsustainable to just deal with the response in a disaster every time it happens. We need to reduce risk, right? When can we take this $430 million and invest it and get billions of dollars in return? That's where we need to focus, and we need to tip the scales as it relates to the use of artificial intelligence to be able to use that in blue skies and mitigation and preparedness versus focusing on AI applications and response. So we are at the cusp of an AI revolution. And I say we're at the cusp because even though it's at the forefront of our consciousness, there's a lot of work that we need to do. One of the things I like to say as a basic analogy is that the machine learning model is really the tip of the iceberg, and below the waterline is data. And if you look at companies like Google and Facebook, their primary objective, first and foremost, is to collect as much data as possible and to curate that data and prep it for analysis. One of the challenges that we have with respect to insurance, inspections, and loss mitigation, and so forth, is we do not have a common data model. So if I'm doing an inspection over here and you're doing an inspection over there, the data that you're bringing in is disparate and disaggregated. And we need to resolve that. We need to come to standards in the industry to have common data models so that we have better data quality and more data to be able to train on. Because the more data we have to train on, the better quality of that data, of course, the more reliable and the more efficacious the model will be at the end of the day. So really, I ask this community that we really should be working together to build common data standards, to build common data models so that we have this treasure trove of data to our disposal to be able to build the models that we need to reduce risk and plan for the next disaster. And with that, I'll be stopping my presentation and looking forward to any questions and answers.
Perfect. All right. For everyone joining, please feel free to type into the Q&A box. I'm just going to end your screen share. All right. Okay. So first question we have is, what is your advice for a senior executive who's trying to convince the C-suite that the rewards of AI far outweigh the risks?
That's a great question. One of the challenges we all have, and regardless of what your field is getting attention of the C-suite or senior leadership. They're dealing with a variety of priorities, and also it's about the bottom line. Why should I spend money here? As I mentioned, with the use of HPC, the convergence of AI and cloud computing, it's extremely cheap, right? So if anything, it's foolish to just ignore the fact that you can run these models for pennies on the dollar when the value way outstrips the risk. So first, from a cost benefit perspective, it's extremely cheap to do it, and much of these models, many of them, are in the open source. So which means that you don't have to spend a ton of money to even onboard these models inside of your cloud computing technology. And one of the silver linings of COVID, as horrible as it's been and the devastation it has created to many lives, we've seen the acceleration of the future of work. More people are working from home. We're using tools like Zoom. Zoom is now terms that my children know, right? These are household understandings that we're now working from home more so than ever. And because of the future of work, we're in a much more distributed environment, and the use of these cloud technologies are more accessible than ever, from your desktop. Yesterday, I had a conversation with a number of universities at the AI Institute. We were talking about how do we close the workforce gap, and that's really the challenge. For a C-suite member is, yes, we can use these AI technologies. Yes, it is very cheap and affordable, but I need to have the internships. The only place these companies really have the skill sets is Google, Silicon Valley, and so forth. But more companies need to be bringing on these skill sets to onboard the technologies and to provide greater value for their enterprises.
Thanks, Sean. We do have some questions starting to roll in. So start with a question. What are the low-hanging AI fruit that the insurance industry can use in CAT management?
That's a great question. So I think the biggest use case that has been most interesting is computer vision and using satellite imagery and classification to understand damage to homes. There's a lot of promise there. And they've done so successfully. We've done so successfully after the Camp Fire in 2018, which devastated the Paradise and Butte County communities in Northern California. We had 90% confidence on the models that we ran. And we're pretty much one-to-one when you compared the on-the-ground inspections of which homes were burned and destroyed versus what the satellite imagery and the machine learning model produced. But the problem that was presented is when the acquisition of the satellite imagery comes in, the fidelity is, the quality and the fidelity of the imagery is not as high. So really taking a mixed approach of using low orbit satellites, fixed wing aircraft, really other points of presence, drones, cameras that may be located like traffic cameras and so forth. As much data, as much imagery as that you can acquire is better, but the confidence of the models are very high. So really the issue isn't does the model work or not. The models are very great, and that's really low hanging fruit. It's more about how quickly and what's the speed on the acquisition and the processing of the imagery that you can bring into the model, and that's the biggest gap. But I would say definitely the lowest hanging fruit is leveraging these machine learning models on satellite imagery that have shown high efficacy, even in the last 4 or 5 years.
Thank you, Sean. We have a couple of questions around standardization. So start with, can you give an example of what type of data should be standardized? Follow-up is that, or a data matrix which is measured differently from institution to institution.
So on data standardization, I'll give you a simple example. The difference between an address versus a lat long versus a geopoint. And those things are important for a number of reasons. One, if I'm using geopoint, that's one data point, that's one column within, a structured data file like a CSV or an Excel file or a JSON structure. The less amount of columns and rows that I have to compute also means that my model is more efficient and runs faster. So, we need to have a consensus around things like location data, as well as time stamping, using Greenwich Mean Time versus using military time versus using UTC and so forth. Having consistency on how we bring in certain data formats is important. To get around that, we've built, and other companies have done this, it's not novel to our company, custom what's called ETL, which is extract, transform, and load functions that, based on whatever the data is coming in, can transform that data into a specific format so there's consistency within your model. But ultimately, what you want to do is when you're setting up your database, you want to make sure that there's a uniform data structure so that your model can ubiquitously and evenly ingest the data into the model for its use, so you reduce error and increase quality.
Thank you, Sean. All right, we have another one over here. So can you share any successful AI application you've seen so far? Many applications are pilot studies, which are hard to expand to regional or national level due to data limit. What's your opinion on the scalability of AI applications?
Well, scale can be hard because there is a problem with generalization, right? So if you're training your model on a particular urban center that doesn't have good applicability to rural areas of the country, that can be a problem. So when you're setting up and training your model, the first and foremost rule should be, how can I achieve as much generalization with this model as possible? And again, that depends on your data fidelity and quality that's coming into the models. The saying goes, garbage in, garbage out. So, but as far as scale as it relates to speed and performance, there are no issues, because when you look at containerization approaches like things like Kubernetes, and the use of, say, for example, Azure Kubernetes services, it scales out automatically with logic triggers that are built directly into the infrastructure. So scale from that perspective isn't an issue, but definitely where it becomes a problem is, again, on that generalization side of, when I build out a model that keeps training within an urban center and I go to apply that to a rural area of the country, uh, it may not be as useful because, there might be a number of factors. For example, you might be using sensor data that is in connected smart cities that aren't available in rural settings and so forth. And so again, it really just depends, or I should say, the best practices are to make sure that those models are as most generalizable as possible. And certainly, if you don't have the in-house residency, what I would recommend is go into a consulting firm who can build you, like a checklist of, who to look for when I'm engaging AI companies or universities that you might want to bring into the fold, having some type of quality assurance, quality control check, so that when they're coming to you, it's not just black box technology and you're not looking into a black box hoping that it's going to succeed, but that you have some type of um, sense of, or a gut check that this is going to be the right approach. And also, I'd recommend, to the C-suite, it might be worthwhile to have on your advisory board or your board of directors a technologist who can really help shape, where the enterprise moves to ensure that you're staying ahead of the curve on the technology and ensuring you're not being sold black box technology that, is snake oil and really too good to be true.
This one flows nicely into this question. So, what are some low-grade ways that risk teams can start implementing AI and machine learning technologies or software that we recommend starting with in order to scale?
Laura, it's hard to hear that question. I don't know if it was on my side or not. Do you mind repeating the question?
So, what are some low-grade ways that risk teams? Can you hear me better now? Okay, perfect. That risk teams can start implementing AI and machine learning technologies into their workflows. Are there any vendors or software that you'd recommend starting with in order to scale?
So thanks for the question. Can you all hear me, or is it bad on my side? You good? Okay. So again, I would start with going to cloud service providers, such as Google Cloud, Amazon Web Services, or Azure. We are a Microsoft startup, so we are a bit biased. Speaking of model bias, we're a bit biased towards the use of Azure services. But there's a lot of turnkey stuff right out of the box. Again, very cheap. We're talking, pennies on the dollar, literally, $3, $5 to run a simple model. But the short story is I would go to uh, the bigger vendors, and then as the team gets more comfortable, maybe you want to run your own local host installation, but I wouldn't spend a lot of money on, say, like an NVIDIA DGX workstation that's going to cost you $250,000 and start running your models locally, although that's going to give you a tremendous amount of speed and performance, which is fantastic. So your workloads will be much quicker. But if you're just trying to get something off the ground, I would strongly recommend going to a cloud service provider, using, playing around with a series of CPU and GPU clusters, and reaching out to the NVIDIA team. They'd be happy to set you up with their insurance vertical, their risk management vertical. They're working with, large banking and insurance institutions around the world, and they have best practices. So there's definitely resources available. And I would start with the companies who build this stuff for a living, Microsoft and NVIDIA.
Thank you, Sean. We have a question from Jim Abraham. Um, meteorological services are moving from forecasting elements to forecasting impacts. A lot of impact data is proprietary. How do you promote open data?
Well, that's another great question. So one of the things that we lead on with Disaster Tech is open source and open data. With respect to the AI Institute, we've all agreed, and it's us, Google, IBM, and NVIDIA. So, big companies, us, a little startup, but we've all agreed to publish our findings on Creative Commons, as well as using open data standards. As it relates to geospatial applications, for example, the shapefile, which is managed by Esri, is proprietary, whereas a JSON or GeoJSON is an open geospatial format. So if we want to democratize both the data as well as the technology, we have to be better stewards of the open source, because ultimately this is all about helping your neighbors and saving lives and reducing risks in communities. And if I can use a model that's helpful in Quebec versus British Columbia, and folks can trade notes and better understand best practices, it's only going to help the whole community. But if we keep things behind a firewall and a paywall, like we've seen in academia, you go look at these research papers and you want to download them, but you can't because they're behind a paywall, and that's a problem. We need to have more openness and open science, open data, open technology to benefit everybody, because with climate change, clock's on the field, and time's going to be up, and we don't have time to waste. We need to be working together as a global community to solve these challenges, and leveraging the most advanced technologies to tackle issues like climate change and global disaster risk.
Thank you, Sean. What advice do you have for folks studying risk management or the insurance profession in terms of how AI and machine learning should inform their decision of what degrees they go on to graduate with? Will the risk manager or insurance professional of the future be highly versed in these technologies?
Well, I think in any industry, you always have specialists. I'm not sure that every risk manager or insurance professional should be expert um, in AI, right? You still need folks who are highly skilled economists and financial specialists. To me, I think that artificial intelligence and technology in general should be part of core curriculum, but that those folks who are interested, can do a dual major in, financial services and technology, or, with an emphasis in AI and machine learning. One of my team members, he dual majored in business and computer science with an emphasis in artificial intelligence, machine learning. So these programs exist, and there's also upskilling, right? If you have an MBA and a bachelor's in finance, go to a community college and do some upskilling to take a certificate program on learning how to code in Python, learning how to code in R, in MATLAB. These technologies are, again, if I download a Jupyter notebook using cloud technology, it's going to cost me pennies. And that's all written in Python, which is common language. And I can go to GitHub to download repositories and start playing around with it. I can get up to speed in literally weeks. Now, granted, it's going to take time to learn how to code, but it's just like learning a language. If folks in Quebec can learn French and English, they can learn Python.
Good one. So we talked a bit about what the insurance industry or policy makers can, or stakeholders can do for low-hanging fruit on AI. But do you have, what are your thoughts on like the top priority around AI and risk mitigation? Like what needs to be done now?
So the top priority again is, I come back to this common data model. It may sound trivial, but it's not, because if we don't have standards on how we collect data and standards on how we store data and transform that data into a unified common data model, it's going to make the use of machine learning that much more challenging. Because again, the saying goes, some models are, or all models are wrong, some models are useful, and to increase the utility of that model, it's based on the quality of the data that's being put into it, as well as how the machine learning model trains over time. It's no different than when you go to CAPTCHA, right? You log into something and says, "Are you a robot?" No, and it brings up the images, right? When you click on the images of the streetlight or the bicycle or the crosswalk, you're actually helping Google train a model, right? That image recognition software is using to train a model, right? And so what Google has done is created a uniform way for those CAPTCHA uh, form verifications that you're not a robot, that you are in fact a human and not a bot or somewhere on the internet. That's all being used to train a model. So the way I see this is we need to have uniform standards. We need to use open standards so that more people can access it. We need to also leverage the crowd. One of the great sort of explosion in disaster management is the use of the crowd, right? And I don't mean from social media, because Twitter is a total mess. Using Twitter data is extremely difficult. Number one, the API that Twitter provides is drinking through a straw versus a fire hose, because you don't get access to the entire data footprint through Twitter. They restrict use on the API. And also, when you're looking at location intelligence, you can obfuscate that. You can use VPN. You could say more generally, I'm in Vancouver versus Victoria, and it will screw up the model. So going back to data quality and curation, is using the crowd. People will self-select. Like for example, in Hurricane Harvey, during a crowdsourcing effort, 700 people volunteered to crowdsource data from people who needed to be rescued off of a roof of their home, or inside of a nursing home, or wherever. And that data has much more quality because it's coming from people who are self-selecting, putting that into the model, right? So to the extent that we have not only uniform and quality on the data model structure, but also quality control on the data inputs.
Thanks. And to go a little bit back to the standardization questions that we had earlier, um, what do you, so it was, what do you think needs to be done? Does there need to be an agency or organization that steps up and says, this is just how it needs to be done? Is there an organization already do that, but might need a bigger voice? What would be the step to moving towards AI being standardized?
Well, I think the conversations tend to be bifurcated, right? So you have the data conversation, then you have the modeling conversation, and those two communities need to come together and harmonize efforts. And that's, you see this too often, where communities are compartmentalized and you create these silos of excellence where there really should be unity of effort. A classical example is law enforcement and the fire service. They've always been the blue and red. It's like they're all working the same team, but they're working in different tracks and not necessarily with unity. And interoperability has always been a challenge, like things like radios talking on the same wavelength, literally and figuratively, having the same common language, right? If I'm working the electric sector, ICS means industrial control system. If I'm working in the fire service, ICS means incident command system. So from the data side and the model side, there needs to be more of a marriage. And yes, there are institutes. In the U.S. side, you have the National Institute of Standards and Technology. You have the NIEM, which is the National Information Information Sharing Model, that has standards. You have ISO at the international level. National Fire Protection Association. There are groups who are trying to standardize, but I always come back to this, that there's lack of unity of effort. And Thad Allen made this most prominent after Deepwater Horizon and his leadership in Hurricane Katrina, is he said, the thing that broke down in the response, both in Katrina and in Deepwater, is we lacked unity of effort. And because we lacked unity of effort, we lacked unity of message. And when we don't have unity of effort, the basic example is we're on a boat, we're all rowing. someone stops rowing in a different direction and the ship or the boat starts to steer. We need to row in the same direction with the unity of effort. So yes, it would be great as an insurance industry, as a financial industry, to come together and to marry the two, data side as well as the modeling side, so that we can create those standards and unified efforts to be able to advance these technologies.
So at the beginning of your presentation, you spoke a lot about how there's been more work done around the response side, looking more towards the mitigation or the proactive side. Are there any items in particular or projects that need to take place that aren't yet occurring to maybe take advantage of the proactive side of things? What would be the top priority there?
So one of my what I believe, and this is purely me speaking as an individual, is that when we've modeled infrastructure systems like grid systems, water systems, wastewater systems, gas systems, pipelines, we tend to model them within their own sector or segment or subsector. And that's a problem because the world is interconnected and things don't work in a silo. As we saw in this pandemic and continue to see, supply chain fragility on things like personal protective equipment or ventilators, or now with respect to the vaccine on cold chain, and how do we maintain refrigeration? But when we've done modeling, typically in the past, in blue skies to understand, what would catastrophic risk be to infrastructure systems, we tend to look at transportation only and the grid only. Whereas, if you've done grid restoration like I have, I was responsible for leading the federal effort on restoring the grid in Puerto Rico after Hurricanes Irma and Maria. And, we only had good fidelity on just what the grid was doing, but we didn't really have understanding of how that had cascading effects across sectors. For example, when we lost power to the fuel farms, we also lost power to transactional systems. So what we ended up doing is we had to fly in literally cash to the island to be able to have a transaction, so that distributors on the downstream side can get gas out of the fuel farm to be able to bring that to gas stations. But then once you get it to the gas station, you had the same problem, that the gas station was without power, and because it didn't have any power, you couldn't get the fuel out of the ground, you couldn't get transactions, no one had cash to be able to pay for the fuel. And so what we need to do is have more of an integrated effort on on these modeling efforts. And the reason why traditionally it's been hard is because it's a massive computational challenge. So for example, we're working with the University of Delaware Disaster Research Center, Cornell University, Stony Brook, UNC Chapel Hill, and Oklahoma University on building these evacuation models if there was an inland flooding or coastal flooding event, whether from a tropical storm or severe weather event. And the problem is that because it takes 5 models in the ensemble, it takes about 60 hours to run that. And why is it? It's because they're using outdated CPU infrastructure, and the code has not been refactored to run on GPUs and in parallelization using high performance computing, right? So a lot of these models, even though they're sound from a math perspective, they have quality data inputs, but they're extremely slow. And when you're trying to evacuate a community, you can't wait 60 hours. You're late for need. So it's going to take a lot of time to get these models from running on legacy infrastructure, working on code bases like Fortran that nobody uses anymore, moving into Python or other modern software languages and so forth. But the challenge really is that these things take a long time, and that's where AI has a lot of promise, because AI, you can train the models over and over again, and you can gain efficiencies by using AI versus traditional physics-based models. And so that's where I think the marriage between physics-based models and AI are going to help speed up these model runs using HPC and cloud technology, so we're not waiting 60 hours for the results to tell me which county should I evacuate first and second, but rather I can do it in minutes or at least a couple hours, so I can, leverage that for decision making.
Yeah, that's so important. 60 hours when something like a hurricane is coming at you is a long time. We do have one final question. We have the AI community are usually located inside university or companies. And this person in particular, they're at a research unit at the University of New Brunswick and have an enormous hydrological data set. Where do you recommend finding collaboration to use this data?
So I'm a big believer in public-private partnerships. If you look at the model we're using at the National Science Foundation AI Institute, it's a combination of government, industry, and academia. The institute is led by the University of Oklahoma and the University of Albany, as well as the University of Washington. And we, again, as I mentioned, our focus is research to operations, right? Working alongside industry and the practitioners so that the practitioners up front identify what are the goals and what are the objectives, what are the desires and business needs of the industry, so that we on the research side, from the onset, making sure that we're conducting research that it's going to meet your goals. One model that I've seen be successful on a private public or university private partnership is using what's called a cooperative research and development agreement, or a CRADA, where the private company enters into a memorandum of agreement with the university, and the private company will fund research, and then that research through the agreement will translate back to the company, or another company that the company may invest in. So, for example, a Southern Company, which is a large power utility holding company in the United States, they've set up an investment arm that they share between multiple utilities, both in the U.S. and Canada, and they invest in companies to specifically work on research areas, one of them being AI, so that it benefits the whole of the industry. Maybe that's something the financial sector should do, is work with the compendium of universities around the world, set up this type of sort of collective pool of money to invest in research and development, and then ensure that there's a pipeline to transfer that R&D from a tech transfer out of the university into a company like a startup, or a much more mature company like an IBM, to sustain it for the benefit of the industry.
Thank you, Sean, and thank you so much for your insights on everything AI and how it can be used in the world of catastrophes. You spoke a lot about how we can't have silos to do this. We need to standardize, and to do that, we have to have public-private university partnerships. We need the data collectors and the data, or the modelers, to speak to each other. So a lot of communication and collaboration that needs to occur. So everyone here today, take that and go look at all the attendees that are attending today, and see if you can start a conversation with somebody who's not in your own sector. So thank you, Sean.